Percent by mass. What is percent by mass? Well, it makes sense that it would be the percent that a single element is of the mass of the whole compound. So if we have a compound like fructose, which is C6H12O6, I can ask the question, what percent by mass is carbon of the whole fructose molecule? Or what percent is hydrogen of the whole, or what percent is oxygen of the whole? And so in doing these calculations, you could do them and then use this percent by mass as a conversion factor if you wanted to convert from moles of the whole compound to to moles of a single atom within that compound. So mass percent is just a useful thing to be able to figure out and know what it means in the world of chemistry. So let's do an example. Fructose. Let's do exactly what I just mentioned before. What percentage is carbon, hydrogen, and oxygen? So to begin with, in order to find the mass of something, you want the mass of 1 mole of compound on the bottom. So that is, what is our molecular weight of fructose? So go ahead and stop the video, perform that calculation, determine the molecular weight, and then come right back. All right, so you should have gotten a molecular weight of 180.1548 grams per mole. So how do we determine what percent carbon is of the whole compound? What you want to do is you want to find the mass of the element in 1 mole of the compound. So how many carbons are there in this whole compound? There are 6 of them. And what is the molecular weight of carbon, the molar mass of carbon? It is 12.011 grams per mole. So you would put that over 180.1548 multiplied by 100 with units of percent. And that will give us a total percentage of 40.0%. So that is our percent by mass of carbon. And we can just repeat this exact same process to determine how much percent by mass wise is hydrogen and oxygen. So hydrogen, there are 12 hydrogens. The mass on the periodic table is 1.0079. And our total molecular weight of our whole compound is 180, not 18, 180.1548 times 100 units of percent, and that will give us an amount of 6.7% hydrogen. Now, does that make sense? Aren't there more hydrogens? Yes, but hydrogens are so much smaller. Remember, they weigh a whole lot less. And so your carbons are bigger, so even though there's only 6 of them, they're going to make up more of the mass of the whole compound. All right, now oxygen. Now I want you just to think about it from a perspective of big versus little. Oxygen has an average atomic mass of around 16. Carbons is only 12. So would you expect it to be more or less percent by mass wise of the whole compound? More. So let's see if that's true. So percent oxygen equals, there are 6 atoms, the mass is 15.999 over the whole mass of the whole compound times 100 with units of percent equals 53.3%. Now, something to look at in order to tell if you calculate this properly, you would imagine that the mass percent of each individual entity adds up to the total mass of everything, and that it does, meaning 40 plus 6.7 plus 53.3 equals around 100%. Sometimes it's like 99.9, depending on how you rounded. All right, so you want all of the numbers of the individual percent by masses to equal 100. If they don't, you made a mistake somewhere. Just go back and check your calculations. But this is how you calculate percent by mass for any specific atom or element within a compound.